Good morning to all. Today we are going to deal about the reservoir topic. Okay. So under the reservoir, we have to calculate the capacity of water. So what is the capacity of reservoir? Okay. In this topic only we are going to deal right now. So the capacity of reservoirs. So course outcomes. The course outcome of this topic is on the successful completion of the course, student will be able to classify the water resources system components per process to meet d- desired. So it is up to understand level. The course outcome of this topic is correlated with the program outcome 1, then program outcome 7, and then program specific outcome 1. So see the reservoir capacity. So depends upon the inflow available and demand. So the inflow is nothing but the inflow in the river is always greater than the demand. There is no storage required. If the inflow in the river is small but the demand is high, a large reserve capacity is required. So it is up to the inflow level. So the inflow is nothing but flow of water in the particular area. The area we are going to build as a reservoir. Okay. So the required capacity for the reservoir can be determined by the following methods. First one is through the graphical method using mass curve. Then second one's based on the analytical method. So now we are going to deal through the graphical method. So the graphical method is prepare a mass inflow curve from the flow hydrograph of the site for a number of consecutive years, including the most critical year, that is the decide years, okay, when the discharge is low. And also we have to prepare the mass demand curve corresponding to the given rate of demand. If the rate of demand is constant, the mass demand curve is straight line. The scale of the mass demand curve should be same as that of the mass inflow curve. So see the picture. The accumulated inflow hacker based in meter, then based on the time like a consecutive years. So see from 1950 to 1954. Okay. So in between we have the 4 consecutive years. So the accumulation of inflow it will be increased. Okay. So see the curve based. Okay. So from here the empty is there, then full is there. Okay. So through the graphical method, full and empty based. Okay. So see A B. Okay. So it is a 1 consecutive years. Okay. So we can take from here the mid of the portion which will be crossed from the C to E. So here the triangle will be formed. So the mass inflow curve we can form it here. So the demand curve, so see 1 year we can take from the M and N. Okay, like C to E we are mentioning. Likewise here the next consecutive year we can take M to N. Okay, so here the curve will be formed. Based on the curve we can take the line. Okay, so see the draw the lines AB comma FG etc such that they are parallel to the mass demand curve and they are tangential to the crest A comma F etc of the mass curve. Then determine the vertical intercept CD, HJ etc. So between the tangential lines and the mass inflow curve, so this intercept indicate the volumes by which the inflow volumes fall short of demand. So assuming that the reservoir is full at point A, so the inflow volume during the period of A is equal to ordinary dG and the demand is equal to ordinate Cg. Thus the storage required is equal to the volume indicated by the intercept CD. So determine the largest of the vertical intercept found in step 4. Okay, so the largest vertical intercept represent the storage capacity actually required. So the following point should be noted: the capacity obtained in the net storage capacity which must be available to meet the demand. The gross capacity of the reservoir will be more than the net storage capacity It is obtained by adding the evaporation and seepage losses to the net storage capacity. So the tangential lines AB, FG, etc. when extended forwarded must intersect the curve. So mid of the position. So this is necessary for the reservoir to become full again. If these lines do not intersect the mass curve, the reservoir will not be filled again. However, very large reservoir sometimes do not get refilled every year. So in that case, they may become full after 2 to 3 years. So the vertical distance such as FL between the successive tangential represent the volume of water spilled over the spillway of the dam. So through the analytical method now we are going to deal. So the capacity of the reservoir is determined from the net inflow and demand. The storage is required when the demand exceeds the net inflow. The total storage required is equal to the sum of the storage required during the various periods. So step 1. Collect the stream flow data at the reservoir site during the critical dry period. Generally, the monthly inflow rates are required. However, for very large reservoirs, the annual inflow rates may be used. Ascertain the discharge to be released downstream to satisfy water rights or to honor the agreement between the states or the cities. So determine the direct precipitation volume falling on reservoir during the month. The precipitation is nothing but rainfall data. Then estimate the evaporation losses which would occur from the reservoir. The pan evaporation data are normally used for the estimation of evaporation losses during the month. So ascertain the demand during various months. Then determine the adjusted inflow during different month as follows. Adjusted inflow is equal to stream inflow plus precipitation minus evaporation minus downstream discharge. Then compute the storage capacity for each month. The storage required is equal to adjusted inflow minus demand. Then determine the total storage capacity of the reservoir by adding the storage required found in step 7. That is storage required is equal to adjusted inflow minus demand. The determination of yield of a reservoir. The yield from a reservoir of a given capacity can be determined by the use of mass inflow curve. Prepare the mass inflow curve from the flow hydrograph of the river. So draw tangents AB, FG, etc. like a triangle based the line at the crest A, F, etc. of the mass inflow curve in such a way that the maximum departure like intercept of this tangent from the mass inflow curve is equal to the given reservoir capacity. So same diagram, okay. So from the see the mass inflow, it will cross 2, 4, 6, 8 based on the years, okay. Then here the storage capacity will be depend upon the H, then C based demands. Then measure the slopes of all the tangent drawn in step 2. Determine the slope of the flattest tangent. Draw the mass demand curve from the slopes of the flattest tangent. C intersect, then intersect, okay. The yield is equal to the slope of this line. So these are the reference material. So two method, graphical based and the analytical method, we can identify the capacity of reservoir. These are the reference material. Thank you.